At one point recently, we looked at solving a right triangle by using the Pythagorean theorem. We had two sides to that triangle, and we wanted to know the resultant of the two blue vectors. It was a displacement situation, but we used the Pythagorean theorem. We said that a squared plus b squared equals c squared. And so we solved for the hypotenuse c. That's great if you know two sides and want the third for a right triangle. But let's say for the moment that you have the hypotenuse and you wish to know the two sides. I've drawn vectors with arrows just because that's where we're going. Let's say that this is 12, and specifically its a velocity is 12 meters per second. And you know the angle, but you don't know a side. Say this is 28 degrees. There's a set of trigonometric functions of trigonometry, that allow us to solve for right triangles if we know one angle and one side. We can find any other side. And some of you may recall, those functions are sine of the angle, cosine of the angle, abbreviated cos, and tangent of the angle, abbreviated tan. In any right triangle, if this is side A, and this is side B, and this is side C, and this is theta, in any right triangle, the ratio of the opposite side to the angle, in this case A is opposite the angle theta, the ratio of the opposite side to the hypotenuse is what we call the sine. So in this triangle, whatever angle theta is, if you were to put it in your calculator and hit the sine of that angle, you would get the ratio of A divided by C. Always, no matter the lengths of any sides, the ratio of two sides is defined by the angle, and therefore these functions give you the ability to solve for one of these when you know the other two. Cosine is the adjacent side to the angle. Now, some might wonder which is adjacent, C or B, because they're both on the sides, but C is always the hypotenuse. The angle opposite the right angle is always the hypotenuse. So this is the adjacent side to this angle. So cos theta would equal B over C. Again, if you knew C and you knew the angle, you could find B. And tangent, which we won't use today, probably, is the ratio of the opposite side to the hypotenuse. So A over, I'm sorry, I misspoke. Opposite over adjacent. The tangent of the angle, theta, is the tangent of the angle theta is the ratio of the opposite side to the adjacent side. So in this triangle that I've drawn for an example up here, it would be side A over side B. There's a little cute mnemonic device to remember that sine is always the opposite over the hypotenuse. In this case, it was A over C. Cosine is always the adjacent over the hypotenuse. And tangent is opposite over adjacent. The cute mnemonic device is SOHCAHTOA. SOHCAHTOA. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. And tangent, opposite over adjacent. And that's just a little review of right triangle trigonometry with the functions sine, cosine, and tangent.